This is our groundwater hydraulics final project, the exploration and assessment of a groundwater pollution remediation.
I'm Erin Kirby.
I'm Miller Egan.
I'm Ryan McKay.
I'm Kayla Mock.
And I'm Kylie Ward.
The purpose of our project is to create an efficient and economical solution to preventing landfill groundwater pollution from entering a nearby stream.
Our original configuration is a contaminated landfill site underlain by a sand and silt aquifer. Because this aquifer is sand and silt, it has a high potential for contaminants to migrate from the aquifer to the surface water. We are thus interested in the outflow to the river because we want to see how much contaminated water is running into the river from the landfill.
All right, so for alternative A, we have our do nothing alternative. As you can see on the right graphic of the heads decrease as we approach the river. This means that the contaminants will flow from the top left corner down to the bottom right corner into the river. From our results, we can see that we have a high river outflow. Since we are doing nothing, all the contaminants that could flow to the river are flowing into the river. And our river inflow is also relatively high. You always need to have a do nothing alternative so you have something to compare it with. And if all the alternatives that we come up with end up being worse off, then the alternative A of do nothing is the most economical and will be the option to go with. Also, because in the long term you'll have to deal with the cleanup of the river and any associated health problems that will occur from the pollution. So it's economical in the short term.
So alternative B has an impermeable cap over the landfill, and this prevents infiltration from rainwater into the landfill. So we reduce the recharge into the site. This option has a slight effect on the flow of water going out of the landfill into the river. So here you can see our outflow is 0.127 feet cubed per second, which is a slight reduction from our do nothing option. And additionally, this option is pretty cheap as well.
So alternative C includes the cap from the previous alternative as well as a confining wall around the landfill. And as we can see from the river outflow, this significantly decreases the contaminants that go towards the river. And it's better than the previous alternatives, but we can still see that there are some contaminants that are heading towards the river, which is not ideal. Alternative D is a cap plus a slurry wall plus a drain, which means that this option adds a drain to the previous option that goes around the landfill. And this option actually increases outflow to the river. And the price is increased from the previous option because of the addition of the drain. And it's less economical because we still have to dispose of the drained water that is bringing contaminants into the river.
Alternative E consists of a cap, slurry wall, drain, and 4 wells. It is essentially our previous alternative with the addition of 4 wells. As you can see on the picture, the 4 wells are between the contaminated site and the river. The flows from these wells is 50 cubic feet per second. It is also our best alternative yet, however it is not very economical. If you note the river outflow, it is down to 0.016 cubic feet per second. What makes it not very economical, though, is the expensive price of the wells themselves and disposing of the pumped water.
All right, next we have alternative F, which combines our cap, our confining wall around the landfill, and adding a confining wall across the river cells. As you can see, this has a very small river outflow of only 0.01 cubic feet per second, And a benefit of this alternative is that there's no added expense of disposing of the water from the drains or the well.
Our alternative G, has 3 wells and a cap. These wells are pumping at a rate of 60 cubic feet per second. Here we see that there is a pretty high contaminant outflow into the river of 0.116 cubic feet per second. Additionally, this option has a negative of having to dispose the water from the wells.
So here we're comparing all of our alternatives. To do this, we looked at the river outflow from each option, as well as the estimated cost. And the estimated cost is based on how much it would cost to remove the contaminated water, as well as the construction costs for each method. And as we can see from the table, option A is the cheapest because we're not doing anything. But it's also not very effective because we have a lot of contamination going towards the river. Option F is comparatively cheap to the other options, but it's also really effective when looking at the river outflows. In conclusion, we recommend alternative F, which is constructing a slurry wall around the landfill and around the river. This has minimal long-term maintenance since you don't have to worry about the disposal of contaminated water from wells or drains. This also is the most reducing alternative since it reduces contaminants by about 94% to the river. And it is also relatively cheap compared to the other alternatives since it has fewer maintenance and lower construction costs.
Lastly, we appreciate you watching our video today, and we would like to congratulate you, Dr. McKinney, on your retirement.
Yay!